Okay, so today we're going to be talking about finding systems of equations, and the first thing we need to do is talk about what are systems of equations. Well, systems of equations are just a group of lines, in this case, that have a common solution. The solution for a system of equations is typically where the two lines cross. So whatever that intersection point is the solution to the system. Sometimes there's infinite, sometimes there's one, sometimes there's no solution. We're going to be looking at this today. So we're going to look at this first one. To find the system's solution, to solve this system by graphing, we're going to graph two lines, and wherever the two lines intersect is the solution to the graph, or to the system. So wherever the two lines cross is the solution to the system of equations. So we're going to start with our first one. This is going to be 1. We're going to write our slope and our y-intercept. For this one, our slope is always the number paired with our x, or the negative 1/2. Our y-intercept is always the constant, or the number without a variable, or positive 2. We're going to start by graphing this. Again, we started our y-intercept. We go to y-axis and go to 2. Our slope is negative 1/2, so that means we're going to go down 1 to the right 2. Down 1 to the right 2. Or we'll go the opposite. We'll go up 1 to the left 2. Like that. This is my, line. All right, so now we're going to look at the second one. The second point, or second line. The slope is always the number paired with our x, so in this case it's negative 2. And remember, if it is an integer or a whole number, it is always going to be over 1. Our y-intercept is our constant, or the number that does not have a variable. In this case, it's going to be negative 1. We're going to start off at negative 1, and our slope is negative 2, 1, so we're going to go down 2 to the right one. Down 2 to the right one, or we'll go opposite, we'll go up 2 to the left one. Our two lines intersect at this point. This is going to be the solution of our system. Looking at this one, the point is going to be negative 2, positive 3. So our point is negative 2, positive 3. That is our answer. This is our solution, negative 2, positive 3. Looking at number 2 on our notes, again, we're going to start off by graphing our two lines. The first line, our slope is always paired with the x. Remember, if there's no number there, it's understood to be a 1. And 1 is a whole number, so it'll be over top of 1. B is equal to the constant, or positive 1. So we're going to start off at positive 1. Our slope is 1, so we're going to go up 1 to the right one, up 1 to the right one, up 1 to the right one, or down 1 to the left one. Remember, it has to be consistent, whatever you do. Like this. For the second one, our slope is always the number paired with our x, or negative 1/4. So that means we're going to go down to the right. And our y-intercept is negative 4. Remember, it's our constant. So we're going to go down to negative 4. Our slope is down 1 to the right 4. 1, 2, 3, 4. So our point, or we go up 1 to the right 4. Or to the left 4. There we go. And this is my line. This intersection point is the solution. So looking at this intersection point, it's at negative 4, negative 3. And that is the solution to my system of equations. Looking at number 3, we're going to do the same thing. The slope for this one is the number paired with our x, or positive 3. Remember, if it's a whole number or an integer, it's always over 1. Our y-intercept is negative 1. So we're going to start off negative 1. Sorry, negative 1. It starts here. Ignore that first point. Negative 1. Our slope is 3 over 1, so that means we're going to go up 3 to the right one. Up 3 to the right one. Or down 3 to the left one. Like that. For our second line, our slope again is 3. And remember, if it's 3, it's going to be over 1. And our y-intercept is positive 3. So our point is going to be here. Now, I can't really go up 3 into the left one, or to the right one, so I'm going to go down 3 to the left one. Down 3 to the left one. And this is going to be my line. Well, if you've noticed with this one, also, I drew it poorly, but it's fine. The lines do not intersect. If they don't intersect at all, if they never intersect, say if these slopes are the same and their y-intercepts are different, it is no solution. If you graph something and it is the same line, then it is an infinite number of solutions. Okay? So for this one, they never cross, so it'll be no solution. Looking at number 4, on your notes, again, we're going to start by graphing our line. Let's start with number 1. The slope is always paired with the x, or negative 1/3. Our y-intercept is positive 1. It's always our constant. We're going to start off at positive 1. Our slope is negative 1/3, so that means you're going to go down 1 to the right 3. Or we can do the opposite. We're going to go up 1 to the left 3. Kind of like that. For our second line, our slope is negative 4/3. Remember, the slope is always paired with your x. And our y-intercept is our constant, or negative 2. We're going to start off at negative 2. Now our slope is negative 4/3. 1, 2, 3. I can't really go down 4, so I'm going to do the opposite. If it's negative 4/3, it's understood to be also 4, negative 3. So that means you're going to go up 4 to the left 3. That is going to be my point. Like that. They intersect at that point right there. That point is negative 3, positive 2. That is our solution. Looking at number 5, again, we're going to do the same thing. We're going to find our y-intercept and our slope for the first point, for the first line, and our second line. Our slope is 3. Remember, if it's a whole number, it is over 1. Our y-intercept is our constant, or 4. So we're going to start off at 0.4. And my slope is 3 over 1, but I can't really go up 3. So remember, if it is a positive number, it can be negative 3 over negative 1, meaning we can go down 3 and to the left 1. Like that. Now for our second graph, it is negative 3. Remember, if it's an integer, it's also going to be just over 1, and our y-intercept is negative 2. We're going to start off at negative 2. Our slope is negative 3, positive 1. Remember, you can do it the other way. We can go up 3 to the right 1. Where they intersect is our solution. In this case, it's negative 1, positive 1. Looking at number 6, same situation. We're going to set up our slope and our y-intercept. For the first graph, our slope is 1/4. Our y-intercept is 3. So we're going to start off at 3. We go up 1 to the right 4. Or down 1 to the left 4. Our slope for this one is 3/2. We know it's because it's paired with our x. Our y-intercept is negative 2. It's always our constant. So we start off at negative 2. Our slope is positive 3. Positive 2. positive 3, positive 2. So this is going to be my line. Like that. They intersect at this specific point, or 4, 4. That is our solution. Now for the next two, these two we are going to have to, oh, that looks really bad. We're going to have to solve for y to begin with. So the first thing I need to do is get y by itself in the first equation and the second equation. So I'm going to write this down here. This is my first equation. I'm going to solve for y by moving my 12x over. If I subtract 12x, that gives me 7y equals negative 12x plus 63. We're going to divide by 7. Y is going to equal negative 12 sevenths x plus 9. My slope is going to be negative 12x over 7, and my y-intercept is 9. We're going to start off there. We're going to start with that information. So our y-intercept is 9. That's our first point. And our slope is negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And positive 7. Right here. And our other one, we need to do the same thing for it. I'm going to write it over here. We still need to solve for y. So I need to get everything that is not y to the other side. This is a negative 4, so we're going to add 4. That gives me 7y equals 4x minus 49. We're going to divide by 7. Those are going to cancel out, giving me y equals 4 sevenths x minus 7. So my y-intercept is negative 7. So we're going to start with that point. And our slope is positive 4 sevenths. Because that is the number that is paired with our x. We're going to go up 4. To the right 7. And down 4. Well, I can't do that, so I'm going to just have to kind of guesstimate like that. That is going to be my line. They intersected exactly this point, or 7, negative 3. Negative 3, yeah. 7, negative 3. 7, negative 3, yeah. And we got one more question to look through. If you guys have any questions along the way, let me know. I'm going to rewrite it. We need to solve for y first, so I'm going to do negative 15y equals 30 plus 21x. We're going to divide by negative 15. Those are going to cancel out, give me y equals 30 divided by negative 15 is negative 2. And 21 over negative 15 is negative, if we simplify, we can simplify this fraction. 21 and 15 both have 3 in common. If I divide it by 3, it's going to be 7 over 5. Negative 7 over 5x minus 2 is equal to y. We're going to start off with our slope, which is negative 7 fifths, and our y-intercept is negative 2. Remember, our y-intercept is the constant, or the number without a variable. We're going to start at negative 2 on the y-axis. That's our first point. Our slope is negative 7, so we're going to go down 7. And to the right 5. Or we'll go opposite, we go up 7. And to the left 5. And this is going to be our graph. Like that. Now we still have to do the other question. We need y by itself. I'm going to move my 2x over. Oops. If I move my 2x over, that gives me 10y equals negative 2x minus 80. I'm going to divide by 10. Those are going to cancel out, giving me y equals negative 2x over 10 minus 8. Now 2 over 10 can simplify. They're both even numbers, so they can both be divided by 2. Negative 2 divided by 2 is negative 1x over 10, which is going to be 5. Our slope is going to be negative 1/5 because that is the number with our x. And our y-intercept is negative 8. We're going to start off at negative 8. Our slope is negative 1/5, so we're going to go down 1 to the right 5. Or up 1 to the right 5, to the left 5. And they intersect at exactly this point, which you guys can tell is negative, so it's positive 5, negative 1, 9. That is our solution. If you guys have questions, all you have to do is graph 2 lines. Wherever they intersect is your solution. If they don't intersect at all, it is no solution. If they are the same line, it's an infinite number of solutions. If you guys have questions, feel free to message me on Schoology.